In this video, we're going to determine equations of regression lines for data and use those equations to make predictions. Let's go ahead and get started here. Let's find the equation of the regression line for the given data, then construct a scatter plot of the data and draw the regression line. The pair of variables have a significant correlation. If we're going to do that, then use the regression equation to predict the value of y for each of the given x values. If meaningful, the table below shows the height in feet and the number of stories of six notable buildings in the city. That should be a pretty perfect correlation because the number of stories is very closely related to a 10 feet per story type thing. So it's a little bit different here because there's going to be some space that is at the bottom and at the top that's going to make that a little different. But we're going to see that there's going to be roughly a correlation here with a slope. So stat edit. The height of the building here is 766 feet, 620 feet, 520 feet, 508 feet, 494 feet, 484 feet. This is my explanatory variable. My response variable is going to be my number of stories, how many floors the building is of occupied space is usually what that is. So now let's go ahead and stat calc, and we want this in ax plus b form, which is number 4, L1, L2, frequency list. There's not one, so I'm going to put a 1 there. Go to just clear that. There we go. All right. Sometimes it wants a 1 there. Regression equation. We talked about this last time, but vars, y vars, function y1, so that we can have the regression equation there. Now, I need to get r and r squared, so I need to show you how to do that. You should only need to do this one time, but come into your mode. If you have an 84, come down here into stat diagnostics and turn them on. If you do not have that option in your mode, go to second catalog, come on down to D right here. Diagnostics on, like that, and turn them on that way. From the catalog, either way, that'll work. Okay. Now that they're on, don't turn them off. We're going to go back here and do that linear regression again. You see that a couple more things popped up here that I'm going to need. So y hat is going to be a x. We want the slope to be to 3 decimal places, so 0.045 x. And then the y-intercept we want to 2 decimal places, so 17.32. Let's go ahead and I'm going to zoom 9. Oh, stat plot, plots on, scatter plot, L1, L2. Now I'm going to zoom 9. There we go. It looks kind of like this one, but let's check that out, that we want to go from 0 to 800, and we're going to go by 200s, it looks like. And then from what looks like to be 0 to 60 by what looks to be 10s. And that definitely looks like C. All right, let's come up here and y equals, and let's make this what we have here 0.04. Let's just clear all this. That's a much more exact version of what I'm going to type in, but I need to get the prediction to match the values that we typed into our boxes up here. So I'm going to predict now when X is 501. Second table, I have my table settings set to ask for my independent variable. So second table, and I want 501 for X. Y is going to be 39.865, something like that. It's about 40. Now predict the value when X is 648, and it looks like the number is 46. We're saying not meaningful if we're outside of our prediction interval here. So our bounds for our what we should be predicting, 484 to 766. If we go outside that range, like 318 is not going to be meaningful because it's outside of this range for which we have data. And 731 is going to be about 50. Yeah, about 50. All right, let's go ahead and let's look at this next example here. And notice that our answers need to be, our prediction interval here is going to be 0 to 5. So we already know that C is not going to be meaningful because 12 is not 0 to 5. Let's go ahead and get started. Stat, edit. Let's clear this list. And let's clear this list. We're going to have 0, 1, 2, 3, 5, 5, and 38, 45, 52, 49, 65, 67. Now, I just told you that we don't want to make predictions that are outside of this interval, yet that's exactly how we use this all the time in business and forecasting and all those things. We just have to. It's the only way that we can use the past 5 years of data to project what's going to happen for the next 5 years and so on. I'm not going to store the regression equation this time because we already saw that we're going to want to do some rounding and stuff like that. So let's get our slope to 3 decimal places, 5.313. Y-intercept 38.5 exactly. We're going to zoom 9, but then let's adjust the window here to go from 0 to 8 by 1s, and then from 0 to, it looks like 80 by what is probably 10s. Let's graph that. Let's get rid of this here, and let's make this 5.313x plus 38.5. We'll graph it. That looks to be like this one right here. Second table, delete, delete, delete. When x is 2, we should have, we're predicted to be 49.1. When x is 2.5, we're predicted to be 51.8. And we already talked about when x is 12, that's not meaningful. When x is 1.5, we're predicted to be 46.5. Let's go ahead and keep going here. Stat, edit, let's clear our lists. And I'm going to need to clear that as well. 150, 170, 120, 90, and 180. So the interval here that I'm interested in for prediction is 90 to 180. And then we have 430, 480, 330, 370, 270, 530. Uh-oh. 150, 170, 120, 90, 180, 430, 480, 330, 370, 75, 30. What did I do wrong? 150, 170, 120. Oh, there's another 120 here. That's what it is. Right. And dimensions match there. That's good. Stat calc number 4. No need to store the linear regression equation. We're going to make it right here. 3 decimal points for the slope, so 2.790, and slope to 3 decimal places, 15.666. All right. Y equals 2.790 x plus 15.666. Window, we're going to have here 0 to 200 by what looks like 10s or 20s. 1, 2, 3, 4, 5, 6, 7, 9, 10. Yeah, by 20s. 20. Then y goes from 0 to 560 by 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. What's 560 divided by 15? Maybe something like that, I think. Just make sure I got the number of tick marks right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 560 divided by 14 sounds better. It's 40. All right. Let's go ahead and let's graph that. That looks very much like D to me. And let's make some predictions here. First, let's see if we're throwing anything out. 60 is too low, so that's not meaningful. All right, second table, 160. It's going to be 462.066. And then 100. It's going to be 294.666. And then 130 is 378.366. And we already talked about 60 is not meaningful because it's outside of my prediction interval here. And that's it for this video. We'll come back next time and we'll start talking about 9.3. See you for the next video.